Hello friends, in this session we will understand the concept of AVL trees. Suppose T is a binary tree with TL and TR as its left and right subtrees. We can say that tree T is height balanced if and only if its subtrees TL and TR are height balanced. An AVL tree is called as height balanced tree when every node in that tree has balance factor BF, which should either be -1, 0 or 1. Let us see what is a balance factor. The balance factor BF of any node in a binary tree is HL minus HR, where HL and HR are the heights of the left and right subtrees of that node. To understand the concept of height balanced tree, consider these two trees. First, let us see tree 1. Here, the height of left subtree HL of root 5 is 1 and the height of right subtree HR is 3. We can calculate BF as HL minus HR, that is 1 minus 3 is equal to -2. Since it is not -1, 0 or 1, tree 1 is not height balanced. For tree 2, the BF is 2 minus 2, which is equal to 0. So, tree 2 is height balanced tree. Let's consider an example to understand the process of constructing the height balanced tree in a better way. Here, we have to insert the weekdays in given sequence. First element is Tuesday, which becomes the root node. Now calculate the balance factor of this node, as height of the left subtree of the root node is 0 and the height of the right subtree is also 0. So, its balance factor is 0. Therefore, the tree is balanced. Next element is Monday, which is alphabetically smaller than Tuesday. So, it is inserted at the left side of Tuesday. Then, calculate the balance factor of both the nodes. For Tuesday, HL is 1 and HR is 0. Therefore, the balance factor of node Tuesday is 1 and the balance factor for Monday is 0 minus 0 is equal to 0. So, the tree is height balanced. Then comes Thursday, which is smaller than Tuesday but greater than Monday. So, it is inserted to the right side of Monday. When Thursday is inserted into the tree, the height of the left subtree of Tuesday becomes 2 and the right subtree is 0. So, BF of Tuesday is now 2 while that of Monday is -1 and Thursday is 0. Now, the tree has become unbalanced. In order to rebalance the tree, a rotation is performed. The rebalancing is carried out using 4 different kinds of rotations: LL, RR, LR and RL. These rotations are performed on the nearest ancestor A of the new node Y, and the balance factor of A should be +2 or -2. First is LL. This rotation is performed when a new node is inserted at the left side of the left subtree of A. Second is RR, in which new node Y is inserted in the right side of the right subtree of A. Next is LR, in that Y is inserted in the right side of the left subtree of A. Last is RL. This rotation is performed when Y is inserted in the left side of the right subtree of A. Now let's come back to the example. The balance factor of Tuesday is 2. It is the ancestor of Thursday, as Thursday is inserted to the left subtree of Tuesday and to the right subtree of Monday. So, the rotation to be performed is LR. To understand the LR case, look at the figure, where 5 is the root node and 4 is the pivot. In LR rotation, a child node takes place of the root node and so the rotation is performed. Now, in the example, the rotation is performed around Tuesday. Here, Thursday will become the root node and Monday will be the left subtree and Tuesday will be the right subtree. Now this is the height balance tree. Next is Saturday, which is inserted to the right side of Monday. Observe that the tree is balanced. Next is Sunday, which is inserted as right subtree of Saturday. Now, here the balance factor of Thursday is 2 and that of Monday is -2. So now the tree is imbalanced. Since Monday is the nearest ancestor with BF as -2, the rotation will be performed around it. As Sunday is inserted to the right subtree of Monday and to the right subtree of Saturday, thus the rotation to be performed is RR. Here 3 is the root node and 5 is the pivot. So in RR rotation, pivot becomes the root node. Observe the rotation. So in the example, Monday is made the left child of Saturday and Saturday becomes the root. Now the tree is balanced. Next is Friday, which is inserted to the left of Monday. Here we find that the balance factor of Thursday becomes 2, which unbalances the tree. Now, as Thursday is the only nearest ancestor of the Friday, so rotation is to be performed around Thursday. Here, Friday is inserted to the left subtree of Thursday. So, the rotation will be LL. In the figure, 5 is the root node and 3 is the pivot. In LL, pivot becomes the new root node. So here, in the example, Saturday becomes the new root. Monday, together with its left subtree, becomes the left subtree of Saturday. Thursday and its right subtree becomes the right subtree of Saturday. As Sunday is greater than Saturday, it is placed on the right side of Saturday. The last element is Wednesday, which is inserted to the right subtree of Saturday. Observe that the tree is now height balanced. So friends, here we learnt how to construct the AVL trees.